Hello everyone, my name is Emily Kuda, and we'll get started in just a moment. But first I just want to conduct a bit of housekeeping. Can you raise your hand using the hand icon to let me know that you can hear me? Great. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, go ahead and enter them in the questions field down below. At the end of the webinar, we'll take time to answer as many questions as possible. At the end of this webinar, a recording and the slides will be made available to everyone within 48 hours or less. I'd like to thank you for attending today's webinar, MySQL in the Cloud, Migration Best Practices, High Availability, and Scaling, presented by Percona CEO and founder, Peter Zaitsev. With that said, I'll turn the floor over to Peter.
Hello, hello everyone. Good morning, afternoon, or wherever time zone it is in the place you are at. So let's get started. So okay, yes, now it works. In this presentation, we will talk about the high-level overview of running MySQL in the cloud. So we'll talk about public and private clouds, databases as a service, to talk a bit about the best practices and migration and scalability approaches, all on a high level, because cloud is a very broad topic, and you really could really fill the days of materials about talking cloud and MySQL in the cloud in general. Because of those, I also had to make a choice as what to cover or not. So you wouldn't hear a lot about containers in this talk, but this is not because I've been living in the cave and haven't heard about containers. This is just because containers is such a big topic and it deserves its own presentation. First, let's cover some basics. Now, when I talk about the cloud, what do I mean by the cloud? And I was thinking, how can we kind of define that so it is clear, right, and simple? I think about the cloud as your dynamic and programmable infrastructure, right? So unlike your conventional data center where putting the new server in would require some manual labor of putting the server in the rack, connecting cables, and so on and so forth, in the cloud, all our cloud infrastructure, servers, storage, networks tend to be dynamic and programmable, right? We can spin up new instances or configure their network paths and all do that all dynamically and through API. And that is the cloud, right? If something corresponds to those criteria, we're talking about that as a cloud. Now, there are two really big groups you can think about the cloud. One is public and another is private. Public cloud is, I think, what is the most conventional, which first comes to our mind when we talk about cloud. It is such as a Microsoft, Amazon AWS, or Google Cloud, Microsoft Cloud. These are all typical examples. And in this case, we have the infrastructure which is provided by a company which is shared with many other users. Now, another way is to run a private cloud, where infrastructure is private for the company. And in many cases, you can hear about some big enterprises having, for example, OpenStack installation in their own data center and running that as a private cloud. Now, additionally, when you talk about the cloud, you probably hear about the concepts which are something as a service. And I think this is an important to understand what exists in the cloud and what all those items are. One way you can sort of consume the cloud services is infrastructure as a service. In this case, is those those items which cloud provides you are pretty much infrastructure level. That's going to be your compute, like essentially your virtual nodes which can run any software you like, your storage, your network. That is one way to do. about that. Now, another, especially in the database world, what is becoming very popular is database as a service. Then you can say, well, you know what, running, let's say, MySQL on EC2 plus EBS, setting up backups and so on and so forth, kind of hard. Maybe we can provide a high level abstraction as a database instance or even a cluster, right? And in this case, it comes to the database as a service. That could be Amazon RDS, Amazon Aurora, Google Cloud Spanner, and so on. Well, there is also another approach where we can say, well, we can be taking those bits and pieces which came to us from a conventional non-cloud environment and taking that in the cloud and still running that kind of in a similar way, or we can go ahead and adopt a full platform which is kind of designed to be typically dynamically scalable and designed to work in a cloud. And this is where the platform as a service comes in. And this is where you would hear the names as Heroku, Amazon, Beanstalk, OpenShift, Google App Engine, among others. Now, another interesting concept which you need to know about the cloud is region and availability zone. The region is something which specifies a geographic region, and typically it comes with hierarchy. So, for example, you may have a region which is defined as North America, West California, right? Which talks that is the region in North America on the west side and in California. Now, with regions, we have a couple of different properties. One is different regions tend to have a complete isolations between them, both on a technical level as well as on geographical level, right? So, for example, some natural disasters may affect the whole region, but that is unlikely they will affect their multiple regions, especially if they are substantially isolated. The downside of those regions is that there is a quite high latency between them, because, well, guess what? Even Amazon haven't figured out how to beat speed of light, and that's why going from, let's say, China to North America takes quite a while. Now, availability zone is located within the region, and typically is designed in a way what it is reasonably isolated from each other, right? But provides better latency. So between the availability zones, the latency is typically substantially better than between different regions, but still worse than the items which resides within the same availability zone. And this is important. Now, if you look at the failure scenarios, right, of course, it's most likely some cloud failures would affect only one availability zone, right? That is kind of by design. So putting your servers in multiple availability zones should give you a reasonable amount of redundancy, right, or availability. Now, there have been known cloud failure which would affect multiple availability zones within same region. So that is not so likely, but it also can happen. You have to consider that in your availability mode. Now, this is how we can make it visual, and I took that image from Amazon Web Services, but pretty much other clouds are typically designed similar. Where you can have multiple regions, which each of them would have the several availability zones available within a given region. Now, also, if you're just starting in the cloud, you should be aware about what are the top cloud providers in the North America, right? So if you look at the North America, Amazon Web Services, that is the biggest one, Google Cloud Platform, and Microsoft Azure or Microsoft Cloud. Those are would be the three largest providers. If you go into some other countries, then the situation may be different, right? So, for example, there Alibaba Cloud is very big in China and in many other countries. There may be some very popular local providers. Now, if you're also looking at the cloud, you should be aware of those the technologies, the open source technologies. One is the OpenStack, which is their leading solution for complete private cloud installation. There is a Kubernetes and Docker, which is the very important companies or projects in their container and Docker ecosystem, which is a increasingly common way to design infrastructure and run application. And then there is a OpenShift, which is a Docker-focused platform by Red Hat, which is getting increasingly popular, especially across the enterprises. Okay, so let's talk about the decisions you may need to do if you are thinking about moving to the cloud. Now, first one is, should you really move to the cloud? Now, as much as that is an important decision, if you are database administrator or developer, this is decision which you rarely have, because moving to the cloud or not cloud is typically a decision which is taken on the somewhere on a high level, right? Let's think about the CIO or somebody very close in the management, right? So in many cases, we see is wherever the team likes what the company is moving to the cloud or frankly hates it, well, that is decision which they often just have to live with. Now, having said that, wherever you move to the cloud right now or not, I believe there are a few things you have to consider. One is programmable infrastructure is really the future. Well, and why is that? Because really, if you have to deal with the large scale applications with many servers, then really doing that manually is just not going to cut it anymore. And it's much easier to automate everything if your infrastructure is programmable, right? So that is why that is a very important strength. Another thing to consider is virtualization, which is what a lot of cloud providers are based on, comes with the overhead. But that overhead is going down over the last few years, and there is less and less overhead from running your applications in virtualized environment. I wouldn't expect that will be exactly zero at all the time, but for most applications that is already quite acceptable. Another thing, of course, to consider is what some cloud providers, they also support the bare metal cloud. I think that is a very important to note. What cloud does not necessarily means is what you have to be virtualized. OpenStack supports the integration to provide the bare metal cloud, as well as that's one of the selling points of the Oracle Cloud. What they do provide you support for bare metal if you need that. So you can use a cloud but bypass virtualization. So let's now talk, as we defined the terms, about their benefits and drawbacks of a different approach to the cloud. We defined what a public and private cloud is, but there is also a hybrid cloud. Where hybrid cloud is then you really have your infrastructure spanning ahead, both your private cloud and some some environments are done in public cloud. For example, what we quite commonly see is somebody saying, well, you know what, our data is so confidential, we don't really quite trust the public cloud yet, so why don't we host stuff still in our private cloud? But for our developers, it's fine if we use public cloud for development, because that comes with more agility, right, and other convenience. Now, so what is the benefits and drawbacks for this public, private, and hybrid cloud? Well, public cloud comes with your agility and scalability. You can spin up one small item, right, or you can spin up 100 or even 1,000 instances today if you have to do something in a public cloud, right? So it's very agility, gives you a very good agility and scalability. And because of that, it can give us a very good costs, especially for small and medium businesses, because investing in stuff to really put the hardware in your own data center and so on and so forth, that really becomes expensive. What private cloud gives you is things like control, because you have much more control what kind of hardware you use. You understand what exactly is going on, how different pieces are connected. Oh, for some large scale corporations which have a staff, it can be less expensive than working with the public cloud, and it's also allows to integrate with your legacy systems much easier. So, for example, if you're still running mainframe and want to connect some system with that at a low latency, it can be tough to integrate that with, let's say, Amazon cloud. But it is much easier if you want to have your new hardware co-located in the same data center where you keep that 30-year-old monster. And that is why you see the private cloud is very well used by enterprise companies. And again, the hybrid cloud is that is when you mix of them, and then you can get the benefits of both, but you can also deal with the cost and extra complexity of both of them. So you have to be very mindful if that is what you use. Now, another approach you can think about is where you are dealing with single vendor or multi-vendor. And by vendor, we mean cloud provider, right? So if you say, hey, we are only using the Amazon, then what is a wonderful thing here is what you can use all features from that what that vendor has to offer, right? And why a lot of cloud providers, they say, all refer to you, provide you certain baseline features, then there is substantial differences among the offerings, right? But the danger in this case is if you really build your application on one single vendor, then that is a danger of being locked in and making the application hard to move from that vendor, especially if you're using some very complicated and not kind of commodity functionality. So, for example, if you're speaking about something like simple as S3, there are a number of providers which offer compatibility with S3, right? So using the basic S3 functionality doesn't lock you in so much. On the other hand, Amazon Aurora for MySQL, that is unique offering, which which only exists on Amazon, and because there is so much unique engineering going to that, then I wouldn't expect something exactly the same to appear on a different cloud provider. Now, if you are speaking about the multi-vendor, then you have to sort of use the lowest common denominator, right, in terms of features which are available across the vendors. But in this case, you can avoid vendor lock-in, and you can shop around. Now, what is interesting in this case is multi-vendor strategy can be employed by some successful or let's say some startups. I've seen a number of companies which would tell us, well, you know what, we spoke with Amazon, they give us some very good rates for 2 years while they have been startup. And when those 2 years have been up, now Google Cloud is investing a lot into making their cloud popular. So they give us some very good rate, and we moved, and that's how we saved a lot of money, right? And that's made sense for them, right? They maybe only working with one vendor, but their application is designed to be multi-vendor capable. On the other hand, you can hear in the news things like Snap or Snapchat having a multi-vendor strategy, really committing to spending hundreds of millions of dollars both with Google and Amazon, just to make sure they have choices. Okay. The next choice you may have is wherever you are running database as a service, for example, Amazon RDS or Google Cloud SQL, or infrastructure on the servers when it comes to a database, right? Then you just go ahead and run MySQL on EC2 with EBS and with backups on S3 and so on and so forth. Now, database as a server is of course easy, and it takes off a number of operational pains. It will do backups for you. It's very easy to deploy. It will upgrade to the new versions and so on and so forth. But at the same time, it's important to know it will take some operational pains, not all operation pains. At least at this point, database as a server, which is not going to tell you, hey, you know what? This is a stupid query, right? And you should not ever get your developers to put that in production, right? Or figure out the indexes you have to you should add things like that, right? Or even warn you when you are about to run into a wall with your current system growth, right? And you have to either fix the system or move to a larger hardware, right? So there are a number of operational pains which are avoided, but it's not all of them. It is less flexible and more restricted. For example, on Amazon RDS, you don't quite get the root account on their MySQL to do what you want, right? You have to you can be more restricted, or even mess around with stuff on the file system level, right, or operating system level. It can get slightly more expensive because, well, you are paying for higher level services, and it comes with more lock-in because it's not such a commodity. Infrastructure as a service, well, you have to roll it your own, so it's harder. You have more operations on your own, or maybe some partner you work with, right? And let's count that as a shameless Percona plug. You can be more flexible. It can get less expensive, especially because of the flexibility. You can run the software of a version or configured in a way which is best suited for your specific optimization. So, for example, if you have a workload which works best with TokuDB storage engine, you can do that on infrastructure as a service, but not yet on Amazon Cloud, because on Amazon RDS, because it doesn't support TokuDB as of yet, right? Now, another interesting thing you should think about is the open source in the cloud. Now, what you hear from many cloud providers is about having solutions which are compatible with open source, right? Saying, hey, well, there is a MySQL, which is wonderful engine, right? Wonderful open source database, or there is a Memcache or Redis, and we have something which is compatible with that on a protocol level. But we went ahead and do some wonderful changes and improvements, right? So it's even better, right? Now, the open source compatible is not the same as open source, and you have to very well recognize that, because some of those improvements they may really mean what that would be very easy, very hard for you to move back to the open source solution if that ever becomes important to you for one reason or another. I think what is interesting in this case, in Amazon case especially, is they when it comes to MySQL, they have it two very separate offerings. there is an Amazon RDS MySQL, which is very, very similar to a MySQL code base. And frankly, moving applications back from Amazon RDS to MySQL proper is relatively easy. Then there is an other stuff, which is an Amazon Aurora, which offers a lot of substantial performance improvements, additional features, much deeper integration with Amazon Cloud. And if you run Amazon Aurora, then moving back to the conventional MySQL can be substantially harder. Okay, let's talk about the migration and the migration best practices. Well, one thing is I believe it's great if you are keeping things simple, right? So for in a lot of cases, I see people trying to do it all together. Hey, we're moving to a cloud. We are also going to upgrade their MySQL version and move to a different kind of deployment topology and so on and so forth, right? Which is making things especially hard and especially risky. What I would recommend is making sure you move to the cloud first, then you use at least the same major version of the software. You can work out all the bugs, or maybe there are some unexpected performance limitations, right? And you can compare apples to apples. And then, if that makes sense for you, you go ahead and do the upgrade. Now, if you move into infrastructure service cloud, then pretty much that works the same as general practices as in your database migrations, right? Data center migrations. As if you would move to their different data center, it's the same. You probably want to use binary backups, for example, done by the Percona Extra Backup, which is allows you to move data much faster than logical backups. You would want to use slave compress protocol or use compression in VPN, so you can catch up your application faster and use less traffic, especially if you are moving to data center where network connection is not very fast. And another thing you would want to consider is your various support utilities may need to be modified for support of the EBS or S3, right? So for example, if you have been relying on LVM snapshot for something, well, now you may want to use a EBS snapshots for that. Then you have been uploading your backups, for example, to some NFS filer in a data server. Now you probably are going to be using S3 for that. And you want to make sure you plan for a time to modify and test the support utilities as well as your core database servers. Now, moving to database servers, well, what you need to do is one is you have to use database dump to copy in most cases. And in this case, you can use a MySQL dump, especially for small databases. But if you're speaking about larger databases, you want to use MySQL pump or MyDumper or some other solutions which allow you to do the dump and restore in parallel. Because especially parallel restore, that can reduce the time to load the database by 10x or more. Now, another thing is for Amazon RDS, while you don't have a root access, there is a store procedure, so you can set up the external master. And this way you can ensure you can catch up your RDS slave server because you are doing the failover. Now, another thing you have to probably change is your monitoring and backups likely will have will need to have some revisions. Well, some of that is because of the good features with Amazon RDS and other database server offer. Another is what chances are you don't have access to a physical box and have a root account, so you have to adjust your strategy here. Now, I mentioned for most database systems, you have to use logical dump, which is not pretty. The great thing for Amazon RDS Aurora is you can actually use Percona Extra Backup to seed the cluster. right? So here is the link to documentation. Now, I would say as we recently tested that, while it works, we were underwhelmed how long did it take us. I think it took us, after backups were uploaded, it took the system about 24 hours to process 100 gigabytes worth of backups, right? Which was substantially longer than we expected. But we're not sure if that was something with that specific incident. And in any case, I think once there is a commitment from Amazon to this feature, that will be becoming better, and those issues will be polished over time. Moving from database as a service. Well, in this case, your logical database dump is probably what you have to count on, especially if you're thinking about something as Amazon Aurora, which doesn't even store the data in conventional file system, right? So there's no file per se. Now, if you look at Amazon, in their case, the replication from database as a server is supported for migration only. So it's not designed or supported for you to constantly be running a replication from database as a service with Amazon RDS to some external node. Now, to be frank, I have not researched that with other cloud providers, and maybe that is different. Now, another thing is what you have to consider, and that is where I've seen a number of people do mistakes and kind of have to start a database dump and copy over, is forgetting to configure MySQL and bin log retention. If you are planning to set up an external slave and it takes you some time to do that, you need to make sure binary logs are retained for a period of time. And so you may want to change the binary log retention for a number of days you need to complete the transfer. Okay, let's now talk more details about some of the best practices. Well, one thing is we are all concerned about, or should be, is cost, being cost efficient. Now, one thing that's important here first is make sure you know your cloud vendor pricing policies, because they are not going to the same as when you just run your own services. And you want to make sure you're going beyond the compute cost. In a number of cases, we've seen their traffic costs or storage costs may be significantly different to just how much it costs to spin up a compute node. Also note, when in terms of price performance, configuration in the cloud is likely to be different, right? So if you got used to thinking, oh, you know what, I can buy this box with so much SSD and so much gigs of memory and blah blah blah, and that is optimal at current market prices, that is not very optimal price performance may be in the cloud, and often you will find what some lower level box may be more advantages. You also want to use in AWS at least features such as reserve instances and spot instances. What reserve instances are is that is a way you can prepay for an instance for a year or 3 years, and that allows you to reduce the cost substantially if you know you will need that instance over time, which is especially the case with databases, because when we deploy the database, we often plan to keep them up for a prolonged period of time, and potentially only grow the deployment. Another thing that Amazon offers is a spot instances. And spot instances is the instances which are currently not in use, like excessive capacity that Amazon has, and they are often available on significantly lower prices, but they have a property what they can be taken away from you pretty much at any time, if somebody who is paying the real money needs them. And those can be good for some sort of testing, which is not performance, not time sensitive, right? So for example, if you want to have an automated backup testing or something else, often stop instances I would be just fine if you just have a policy you need to do that approximately once a month, right? Because, well, you will find the time in that month to find this available. Another thing to consider is to understand the difference between what cloud guarantees you as a performance of resource and what is the burst up to what extent that resource can burst to. The guaranteed is what really performance is going to be in essentially in a worst case scenario. And that is what you pay for, and that is what you should plan for. The burst is a performance resource can provide in some case in time, and it's typically not guaranteed, and often it's limited in length to prevent an abuse. For example, if you use if you're a burstable compute instance in Amazon, or if you are not using provision IOPS, that's how your storage will behave. And the problem with such burst is if you are running some short benchmarks and some short tests, you may be getting very good performance. You may assume what that is, how the system will behave, put it in production, and then it becomes significantly slower because you are you burst as much of a burst credits you had, and now you have been throttled to significantly lower performance, which can be 1/10 of what you were able to burst in. So be very careful with that. And one of a good solution in this case is make sure what then you are doing some benchmarks and capacity planning, observe a workload for prolonged period of time, not minutes but hours, right? Or I would suggest that the 24 hours, so you can observe all the variance, ebbs and flows better. Now, in terms of network, I would suggest you really understand the application to the database network latency, especially that. Why is that most important? Well, because while from a user accessing your system from the internet, it may be one page view or one API request, often it will take tens or even hundreds of database queries on the backend to produce that result set, with latency adding up in many cases. Right, so application to the database latency because of that is much more critical, and your application may be much more sensitive to that. As we discussed, same AZ is then those things are going to be optimal, but at least the same region is a must. Now, in a lot of cases, even if you are deploying your database cluster in multiple AZ, you may want to have your application nodes deployed across the same AZs and talking to the local nodes where it's possible to reduce the latency. You want to make sure there is a 100 gigabit network or 10 gigabit network at least available for you, and also understand the concept of jitter. What happens in the cloud networks is because there are so many users and because you really don't know through what kind of route your paths take, through how many switches and routers and so on and so forth. It's very hard to understand what exactly the jitter is going to be, right? And that is where testing or using some reliable source which have done a testing for you can be valuable to really understand how how latency changes over time, right? And what really has been history of a worst case latency of throughput for some period of time. Now, we spoke about the latency here, and really latency is the most important for most applications, but bandwidth also can be important for things like database dumps or batch jobs. Now, CPU, well, it's pretty much the same whether you're in the cloud or not, And I would just point out that the MySQL uses a single thread for single query. So you often want to have a faster cores when you have a chance, while multi-core gives you some good scalability if you're looking for web workloads with short queries and a lot of concurrent users. In terms of memory, we are using memory mainly as a cache when it comes for MySQL, and that is very important for performance, especially in the cloud, where storage is typically not as fast, right? So to keep that in mind. When you speak about storage, there are three general types of storage what cloud offers. There is an instance local storage, which may or may not be available, and typically it's not something which is highly available. You should always count on possibility of an instance in the cloud dies and taking everything which was local to that instance with it and becoming completely unavailable. What is good about that instance local storage, it can be very high performance, like you can get a pretty high performance flash available out there, and it can be relatively inexpensive compared to the cloud block storage. Now, your cloud block storage, such as EBS, is something which is reliable, but at the same time, it's kind of remote compared to in relationship to the instance, and because of that, it has significantly higher latency compared to the local flash, which is just connected to the node directly for PCI Express. And you also have to pay separately for that storage and right, for space and for IOs. Also, you typically have a file/object store in the cloud, which doesn't provide interactive block level access, but is good to storing files, right? Storing images, right, to static HTML, that is what we can often see in general. When it comes to a database, that is often very good for storing the backups, storing the logs, and so on and so forth, right? That's what we use that. Now, a thing to note in this case is what when we look about all those kind of options, network performance, how much local storage I have, what kind of CPU, and so on and so forth, you can't really get any combination you want. There are some specific instance sizes which are provided, and they typically also have some other performance consideration to external components. For example, you can't have a micro instance with a largest, fastest performance EBS connected to that, right? So you need to really understand that to see what's available. If you're storing your database on EBS, you want to make sure you have a provision IOPS for optimal performance, or at very least understand how much IOPS are you sort of expected to get, right, and not count on the burst how much IOPS storage provides. You'll find a lot of horror stories about using non-provisioned EBS for MySQL, but in most of those cases, people simply didn't understand what bursting means and how much performance we should have counted on. For backups, Glacier storage can be very helpful, especially for old backups which you are unlikely to need. It can be very substantially lower portion compared to EC2. Operating system, we want in this case you consider some cloud optimized Linux versions, but at least use a recent Linux version, because all the recent Linux versions they have a lot of use in the cloud and they're typically pretty good optimized. One thing I would warn though, if you're using cloud-only Linux, let's say the Amazon Linux, and you have also some development which happens outside of cloud, you may run into some inconsistencies between, let's say, CentOS and Amazon Linux. For some folks, that has been important. Some others just don't care. For MySQL, you want to use a recent version for the same reason, and don't count on the good defaults because MySQL configuration by default, well, is not designed for performance. Database as a service. Well, it's good to understand what in the end database as a service runs on the same physical hardware pieces and the infrastructure, right? So in a lot of cases, thinking about the same properties for components, it would apply. One thing I would also point out in this case is what you should not be thinking as database as a service is always faster, right? This is just one of the benchmarks, right? And there are many other benchmarks where Amazon RDS Aurora is indeed much faster, but you can see that doesn't apply in all cases. Okay, let's talk about the availability briefly. Your choice of availability is you either roll your own or use database as a service and the availability it provides you. Now, things to consider in the cloud is what you have a lot less control or even visibility in the infrastructure, right? So, for example, things which you may use in your data center, such as IP takeover or even kind of MAC address takeover, may not really work in the cloud. In a lot of cases, you would see load balancers being used in the cloud. One that you often would have something like a cloud, a load balancer such as Elastic Load Balancer at AWS, which is fantastic in a way. It's well integrated in the cloud. It's kind of manages its own availability and so on and so forth. You can also use some open source load balancers such as HA proxy or proxy SQL, or you can use combination of them. So, for example, you can use a cloud load balancer just to kind of do some sort of a round robin traffic balancing across multiple proxy SQL instances, which at the same time can do some more smart things for you, such as a query routing, read-write splitting, and so on and so forth, which cloud load balancer is not designed to do. When maintaining copies of data, there are several choices for you, right? You can use MySQL replication, you can use a MySQL group replication, or you can use Percona XDB cluster or PXE or other Galera technologies. Nothing pretty much changes here. Now, I would point out what we have a lot of traction with Percona XDB cluster used in the cloud, because it really works very well. You can, as a cluster, you can really deploy it in a way you can read to any node and write to any node, and it works very well with simple load balancer if I choose to. It really provides automatic provisioning, and you can after scale that. So you want more capacity, especially for reads, you add a node to the cluster. You can also run it with a local instance storage, which for some workloads can provide you substantial performance benefits and reduce the costs. And it's also designed in a way it requires only single round trip per transaction commit. That means it's designed very well for deployment across multiple availability zones, while providing no data loss in case of failure. Now let's talk about scaling a little bit. Now, in case of scaling, there are some things in the cloud are better and some things which are worse. Better is because cloud provides some very optimized options, such as Amazon Aurora. But it's also worse because they have a lot of restricted hardware choices, right? There are certain things which we may know works great, but just not available in the cloud. Now, there are two ways you can essentially approach scaling. You can either scaling up, vertical scaling, right? Scale up with your hardware size, get more CPUs, more memory, faster storage, and more storage, or scaling out, horizontal scale. And that is where you scale by adding the nodes. Now, scaling up has a bad reputation, right? We'll say, well, you can't really build Facebook by scaling up. And this is, of course, right. But for many applications of a medium size, scaling up is, especially with MySQL, is really a good choice, because single MySQL instance on a commodity hardware is quite powerful. You can deal with several terabytes of database size. You can have hundreds of thousands of queries per second for a single node, and even more if you use some replicas. And you can even update more than 100,000 rows a second, which allows you to build pretty powerful applications. Now let's think about scaling. What can do we have to scale with MySQL? Well, if you think about that, you have to scale read queries, scale write queries, and scale in terms of the data size, which tends to grow as your applications grow. For scaling reads, we are often doing things like replication, right? That has been a way to scale reads with MySQL for now more than a decade. Same applies to caching. We can employ something like memcache, Redis, or caching built in proxy SQL to cache some queries and reduce the load. Or we can move some load away from MySQL. So, for example, a lot of folks would use Elastic for full text search because that is not MySQL is particularly good at, or run the large-scale analytical queries on solutions like Hadoop or ClickHouse, which are much better suited for this. In terms of scaling writes, well, new MySQL versions tend to perform better, especially because of parallel replication. Because in many cases previously, the limitation of the MySQL performance wouldn't be because of how many writes it can take, but how many writes it can replicate, right? And if you can't replicate, well, you have to reduce their load on the masters. It's never will be able to catch up, especially if you are having a lot of inserts, right? Like you have a login workload or something. Consider TokuDB. It has allows you to get much better performance and allow to scaling writes much better. And you also often just have to separate your data into the different pieces and move it to a different nodes or clusters, such as function partitioning. Then you may be able to put some sets of tables on one set of servers and another. And sharding, when you chop your data, putting, for example, different users on the different clusters. Now, sharding is not easy with MySQL, and a lot of applications use the manual the sharding approach. But I wanted to highlight a couple of new developments which make me very excited about sharding in MySQL. One is the proxy SQL, which I mentioned a few times already, and that is one of the things that proxy SQL can be good at, is providing you with simple basic sharding. Another solution is VTES, which was recently updated to support native MySQL protocol, and I think that is a very cool technology you may want to evaluate if you are considering implementing sharding for MySQL now. Scaling data size. With a data size, you may want to consider those things. One, as I mentioned, functional partitioning is very obvious choice. It allows you to have a less database size per node as well. Data archiving. In so many cases, we find what their database is bloated because it has some data it shouldn't have. And simply archiving that, putting that as a text dump files in S3, right, or in Hadoop, or maybe even to instant MySQL, different MySQL instance can often dramatically reduce database size. If you're using for heavy level of compressions, you can use TokuDB. Often that can give you several times better compression than InnoDB DB compression. And if you are limited by your database size, then that's a thing to consider. And often note what in many cases it's not going to be about the MySQL application MySQL performance itself, which can drive your needs to reduce the data size, but operational needs. For example, how long that takes you to provision the new instance copy of data, or how long backup and restore would take. Yeah, in many cases, you can have a tens of a terabytes of a database performing quite okay with MySQL, but managing such database size on a single instance can be painful, especially if you don't have a very fast network. Okay, well, on this note, I wanted to also announce that we have a call for papers for our Percona Live in Europe is now open, which will take place in Dublin, Ireland this year. And we would like to invite you all to submit your proposal. And with this, Emily, I am happy to take a couple of questions.
Okay, thank you so much for that, Peter. So at this time, go ahead and enter your questions down in the questions field, and we'll get started. So our first question is, what is the fastest way to verify and validate backups created by Percona Extra Backup for a database with the size of 2 to 3 terabytes?
Well, I think that is all a question of how much validation do you want, right? So their very basic thing is, of course, is you may want to just restore a backup, right, and make sure what the Percona Extra Backup apply logs complete successfully. That is level one. The level two, I would say, is when you restore a backup and run check tables on all the tables restored, right? And if you had some tables which become logically corrupted for some reason, you wouldn't store that. But that doesn't really guarantee what the database is in sync before they had in production. Now, if you really want to be sure, then you can restore your backup, connect that as a slave, at least temporarily, and use PT online schema change to ensure the data you restored, right, and after replication caught up, is exactly the same as a master, right? And that is what essentially validates what the backup matches where it was taken from.
Thanks so much. So we are getting close to the top of the hour, so I'm gonna squeeze in one more question. Is it possible to run Percona Extra Backup on Aurora?
Well, that is amazing. A lot of Percona Extra Backup questions, right? I think we just had a Percona Extra Backup webinar a couple of days ago, and they had a ton of questions during that one as well. So I am very happy Percona Extra Backup is getting so many users and so much attention. But the answer is no, you can't run Percona Extra Backup on Aurora because, well, you don't have any access to physical storage on Aurora, and it doesn't really even quite stores the data the same way as a MySQL in DB does, right? So if there would be some feature to create Percona Extra Backup restore backups, compatible backups, right? It would be for the engineering team at Amazon to do that.
All right. Well, I've just recorded all of the questions. Go ahead and continue. Keep sending them in. And with that said, I just want to thank everybody so much for attending today's webinar. Thank you so much, Peter, for presenting today. It was very helpful, and we learned a lot. And everybody, please enjoy the rest of your afternoon, and we'll conclude. Thank you.
Thank you.